Namaste everyone. Welcome to second PUC theory physics class. We were in atoms. We have finished almost all the theory part except one thing, that is excitation potential, excitation energy, ionization energy and ionization potential. That you have to finish. I will explain it and along with the problems, right? So today we will look into some problems. Very important problems that you get in the theory exam as well as in entrance exam. Very easy problems also. Namaste, welcome to the classes. Yeah, shall we move on directly? Yes, we have some 5 to 6 problems. Wavelength of first member of Lyman series is 1216 angstroms. What is the, calculate the wavelength of the third member of Balmer series? Yes. Before going to the problem, let me remind that formula, that wave number using which Bohr was able to explain all the spectral series of hydrogen atom. 1 by lambda is equal to Rydberg constant into 1 by n1 square minus 1 by n2 square, where n1 and n2 are the quantum numbers, higher energy level number, lower energy level number, higher energy level n2, lower energy level n1. Now the question is, it is the first one is given, and why it is given like this? Sir, it is asked, calculate the wavelength of the third member of Balmer series. Directly it is asked. Sir, why can't I substitute directly for the second half? Why that first part is needed? Whether it is needed actually, yeah, it is needed. You can directly get the answer from the second part. Calculate the wavelength of the third member of Balmer series. You see, jumping to 1, I don't write it on the board. Jumping to 1, 2 to 1, 3 to 1, 4 to 1, 5 to 1, or Lyman series. 2, second energy level. So, transition occurring from any of the higher energy levels to the second energy level. 3 to 2, 4 to 2, 5 to 2, Balmer series. Third member of Balmer series. Third member of Balmer series. 3 to 2, 1. 4 to 2, 2. 5 to 2, right? N1 is equal to 2, N2 is equal to 5. 3 to 2, 1. That is H gamma, right? H gamma line. H alpha, H beta, H gamma. H alpha 3 to 2, H beta 4 to 2, H gamma 5 to 2. They are asking H gamma line. Substitute 2 and 5. Rydberg constant 1.09 into 10 to the power 7. You will get directly the answer. But remember, you are not supposed to remember the value of Rydberg constant. Remember that you should not use the formula of Rydberg constant directly unless it is given. If it is given, you use it. Otherwise, you are not supposed to use it. So, what is the problem here? You have to find out the Rydberg constant from the first part and then apply it. Suppose by chance in the theory exam, if you use the Rydberg constant which is not given in the problem, you are gone. You won't get full mark. So, what you have to do is here, the first part has to be used to find out the Rydberg constant. Then for the second part, use the same. Let me do that then. The wavelength of the first member of Lyman series. First member of Lyman. What is that? 2 to 1. Correct? N2 is 2, N1 is 1. That wavelength is given. 1 by 1216 angstroms. What is angstrom? 10 to the power minus 10. Fermi, 10 to the power minus 15. Nano, 10 to the power minus 9. Micro, 10 to the power minus 6. You should be very thorough with all those things. So, first member of Lyman series is RH into 1 by lower one, N1 square, N2 square, like this. So, from this you will get Rydberg constant. What is that? 1 by 1216 angstroms is equal to Rydberg constant into 1 by 1 minus 1 by 4. What is this one? 1 by 1216 into 10 to the power minus 10 is equal to how much? This is 3 by 4. 1 minus 1 quarter, 3 by 4 RH. So, what is RH? Rydberg constant. Rydberg constant for hydrogen is equal to, it is 4 by 3 times, what is 4 by 3 times 1 by 1216 into 10 to the power minus 10. This is RH. So, if you calculate this, will you get 1.09 into 10 to the power 7? Yes, you will get it. You can check it. 4 divided by 3 divided by 1216. Yes, 1.09 into 10 to the power 7, you get it. Okay, now go to the second part. You should act as if you don't know RH. You should act like that. You don't assume it. If it is given, you take it. Sometimes you need not act because you may not be knowing the RH value itself. No problem, right? You you have to act as if you are acting, right? You need not be in reality. You will not be knowing the value itself. Okay, but you remember the Rydberg constant value that is needed. Okay, now substitute the value for the second one. What is the wavelength of the third member of Balmer series? For the third member of Balmer series, 1 by lambda is equal to same RH into, what is the third member? It is 1 by 2 square minus 1 by 5 square. So 1 by lambda is equal to RH. So shall I substitute it as, this is calculated already, 1.09 into 10 to the power 7, 1.09 into 10 to the power 7 into 1 by 4 minus 1 by 25. 5 to 2, 3 to 2, 4 to 2, 5 to 2, third member. So what is this one? 1 by lambda is equal to 1.09 into 10 to the power 7 into 100, we will take it as common. What is here? 425s are, 25 4s are 21. That is equal to, directly we will calculate it. I will calculate it and reverse it, right? I will write lambda itself directly equal to, because the reciprocal of this 100 divided by 21 divided by 1.09, 0.09, that is equal to 4.36, yes, 4.36 into 10 to the power minus 7 meter lambda. And if you want to put it in 4.343 I got, I think I have not written all the values here, 4.36 I got, into 10 to the power minus angstroms, 10 if you want, 4.36 into 10 to the power minus 7 into 10 to the power 3 divided by 10 to the power 3. Multiply and divide by 10 to the power 3. This will make 10 to the power minus 10. This will make 4360 angstroms. Here 343. Okay, let it be, no problem. So that's how we have to do. And you can do one thing. You can write this formula. Where is it? Yeah. You can write this formula. And you can write this formula and directly divide it. Here also you take it as RH. Don't find out RH. You can divide these two equations directly and then also you can do that. There is no rule that you have to find out RH and substitute it in the next formula. Take RH as RH only. Here also RH. Divided. Rydberg constant for hydrogen gets cancelled. So that is also one of the method. Okay, so first problem finished. Second one. Calculate the Rydberg constant, same thing. If the wavelength of first member of Lyman series, same thing, 1215 angstrom. Hence find the wavelength of the hole. And also, this is same problem, right? Hence find the wavelength of the third member of Balmer series. I haven't seen this. Also calculate the frequency of the same line. Okay, we will find out the frequency of the same line. We have got lambda, we will continue it. We will continue the same problem. We have got lambda. What is nu is equal to? Nu is equal to C by lambda. What is C? 3 into 10 to the power 8 by, what is lambda? Of course, 1 by lambda itself we have got 4360 angstroms. Here it is 4341. Okay, I will use this one. You check it later, angstroms. What is this answer? That is finished. Nu is equal to C by lambda, 3 divided by 4360 0.00030 0.0006880. You are getting 6880 into 10 to the power 18. Yeah, 6 point if you want, 1, 2, 3, 4. 4 zeros you have to bring it from here. 6.88 into 10 to the power 14. Frequency hertz. Answer is here. Somewhere I have approximated it, so check it once. You may get the correct answer. Okay, third one. Calculate the wave number, wavelength and frequency of H beta line of hydrogen spectrum. R is given. Directly you can do that. Yes, we will do that. Very quickly you can do it. Say similar type of problems you have here. Identical types of problems. Okay. Calculate the wave number, wavelength and frequency. Wave number 1 by lambda Rydberg constant for H beta line, H alpha 3 to 2. It is in Balmer series. H beta 4 to 2. N1 is equal to 2, N2 is equal to 4. H beta line. So N2 is equal to R into 1 by N1 square minus N2 square. Nu bar is equal to Rydberg constant 1.097 into 10 to the power 7. 1 by 4 minus 1 by 16. Nu bar wave number 1.09 into 10 to the power 7. 16 common. 4 4s are 16 1s are. Nu bar is equal to 1.09 into 10 to the power 7, 3 by 16 is equal to. And remember, wave number has the reciprocal of wavelength, so it is meter to the power minus 1. So let me calculate. 1.097 divided by into 3 divided by 16. 0.205, yes, 0.205 into 10 to the power 7, 68 you have, 7 into 10 to the power 7 meter to the power minus 1. Now you get the reciprocal of this, that is lambda. Lambda is equal to 1 by nu bar, because nu bar is equal to 1 by lambda. So 1 divided by 0.2057, correct? That is equal to 4.86 into 10 to the power minus 7. Reciprocal of this 1 by 0.2, 10 to the power 7 when it comes to the numerator, so it's 10 to the power minus 7. You want it in nanometer? Oh, it's not nanometer. 448.6 nanometer it should be, or 4000. No, it cannot be so much nanometer. 448.6, 448, 486 point. There is something wrong in this. Check it yourself, right? That is right, 0.2057. 1 divided by 0.2057 is equal to lambda 1 by nu bar 4.86 into 10 to the power minus 7. So multiply and divide by 100 if you want it in nanometer. Divide by 100 will make minus 9. This one 486.1 nanometer. It should be 486.1 nanometer. You have to correct it. Check it and tell me whether this is wrong or right. If it is right, okay, no problem. If it is wrong, again this is also wrong, you just inform me, okay? 486.1 nanometer. Right. Then what is the other one? Frequency. Nu is equal to C by lambda. That is equal to C 3 into 10 to the power 8 by lambda. This 486.1 nano. So 3 divided by 486.1, 0.006617 into 10 to the power 17. This is correct. If this is correct, this is wrong. This is right. 0.00617 into 10 to the power 17. Nu is equal to 6.1. If you want, you have to take 3 zeros from here. So 14. 6.17 into 10 to the power 14 hertz. That is frequency. Yes. Simple problem. Similar problems. We will go to a different problem now. Calculate the kinetic energy, potential energy and total energy of the electron in the first orbit of hydrogen atom. So you know the first orbit, it is 0.53 angstroms. Given the radius of the first orbit is 0.53 angstroms, and you have to get this answer. Minus total energy should be minus. Sorry, this is plus. What is that first one? Calculate the kinetic energy. Yes, plus. Correct. Yes. Now, what are the formulas? Total energy of the electron is minus z square, of course 1 square, e to the power 4m 8 epsilon naught square n square h square. Total energy. Kinetic energy is same, plus z square e to the power 4m divided by 8 epsilon naught square n square h square. Potential energy, z square minus e to the power 4m divided by 4 epsilon naught square n square h square. Why it is minus? Potential bound energy, right? It is negative. 1 by 4 pi epsilon naught q1 q2 by r. When you use that, charge of the electron is negative. So minus then by r. So what we can do? First of all, we will find out this. Double it, you will get potential energy. First of all, we will find out the kinetic energy. Kinetic energy first. Z square 1 square e to the power 4 1.609 into 10 to the power minus 19 to the power 4 m 9.1 into 10 to the power minus 31 kg 8 epsilon naught 8.854 into 10 to the power minus 12 n square first orbit 1 square h square 6.6 into 10 to the power minus 34, that is equal to, we will write it, 1.609. Charge of electron, right? 2, 1.602 e to the power 4 1.602 into 1.602 6.578 into 10 to the power minus 76, right? Z square e to the power 4 m 9.1 into 10 to the power minus 31 8 epsilon naught square 8.854 into 8.854 78.39 10 to the power minus 24, this one, this h square, isn't it? 8 epsilon naught square n square h square. So 6.6 into 6.6, 6.6 into 6.6, 6.6 into 6.6, 43.56, 43.56 into 10 to the power square minus 68. Okay. Yes. So what is the answer? Total energy 6.578 into 9.1, okay, divided by this 8 is equal to, divided by 78.39 equal to, divided by 43.56 0.00219 into 10 to the power, this is how much? Minus 76 minus 31, 107 What about here? Minus 24 minus 68. 12 and 92. Minus 92. Minus 92 and 107. Somewhere gone wrong. 31 minus so minus 24 minus 68. 68 minus 24, 31, 107 minus 92. 92, 102, 10, yeah, 15, right? 107 minus 92, 8, 8, yeah, 10 to the power, this comes minus plus, minus 15. How much is this one? That is equal to, I will write it in 19 form because I have to convert it into joules, electron volt. 10 to the power minus 19. However, I am going to divide it by 1.602 in 10 to the power minus 19. So, minus 15 here. 1, 2, 3, 4. 21.9 into 10 to the power minus 19 joules. How to convert it into electron volt? 21.9 into 10 to the power minus 19 joules divided by 1.602 into 10 to the power minus 19. 21.9 divided by 1.602 is equal to 13.67. 0.67 electron volt. We have forgotten minus, 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 minus. Minus 13.67 electron volt. We got it. Now, are you ready to substitute here? Not required. Why? Simply say that this is negative. Sorry, this is kinetic energy, right? Plus, 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 plus. Got mad after substituting all those values, right? So it is plus. What about potential energy? Same amount, minus 13.6 eV, plus 13.6 eV. What about this one? Total energy. Sorry. Potential energy is not minus. This is minus 13.6 eV because these two are same. This is plus 13.6 eV. What about potential? Double. If you multiply this by 2, it becomes 1 by 4. That is 13.6 plus 13.6. 27.2 electron volt with negative sign. Is it minus 27.2, 13.56? Yes. You will get that. Okay. We will move on to the next question. Fifth one. Electron in the hydrogen atom jumps from higher energy minus 3.4 electron volt to lower energy minus 13.6 electron volt. Calculate the wavelength of the light radiation emitted and to which region does it belong? Yeah, this is a good question. Entirely different, and last one is not a bad question, but so much amount of substitution. Okay, so electron jumps from one energy level. Minus 3.4 is greater energy level, and plus 30, minus 13.6 is lower energy level. Calculate the wavelength of light radiation emitted and to which region does it belong? Okay. Minus 3.4 means 2 to 1 it is, right? It is by 2 square, that means by 4 is this one. That means 2 to 1. It is Lyman series. It is ultraviolet region. That is correct. Balmer series is partly in ultraviolet, then visible 3, H alpha, H beta, H gamma, then infrared. Okay, now how to calculate that wavelength? You know that energy emitted E2 minus E1 must be equal to H nu. Wavelength, if you want, Hc by lambda. E2, what is E2? Minus 3.4 minus E1 minus 13.6. Got it? Minus 13.6 lower, minus 3.4 higher. So when it jumps, we get H nu. And minus 3.4 minus of minus 13.6, that is equal to Sc by lambda, 6.6 into 10 to the power minus 34, 3 into 10 to the power 8, lambda we don't know. But one major mistake we have done here. Can you tell me what is a major mistake? If you substitute H value in SI system, C value in SI system, and want to get lambda in meters SI system, left hand side should be in SI system. What is SI system of energy? It is not electron volt, it is the joules. So conversion of electron volt to joules, 1.6 into 10 to the power minus 19. This is to convert electron volt to joule, because this is electron volt difference. We have to convert it into joules. Okay, bring this one here. What you will get? 13.6 plus minus 3.4 is equal to, bring this one here. I got a, okay, let it be. 6.16, this is 19, right? 19.8 into 10 to the power minus 26 by lambda. What is lambda? 19.8 into 10 to the power minus 26 by, this is, where is 1? This we have not written, into 1.6 into 10 to the power minus 19, and this is 10.2 now. This answer is 10.2. 10.2 into 1.6 into 10 to the power minus 19. That is equal to 19.8 divided by 10.2 divided by 1.6. 1.213 into 10 to the power, what is this? 19 plus 19 plus 19 minus 26, 7 minus 1213 into 10 to the power minus 7. And if you want it in angstroms, multiply by 10 to the power 3, divide by 10 to the power 3, that is equal to, this will make 10 to the power minus 10. What this one? 1213 into 10 to the power minus 10 meters wavelength angstroms. So the little bit of change, angstroms, that is the answer, right? So that is what you have to do. But in these types of problems, when you subtract this, remember you should convert it into joules, even in entrance exam problems. Okay, sixth one. On going to a higher energy, on giving energy to a hydrogen atom, transition occurs from energy level 1 to energy level 4. Okay, it goes to the higher energy state after giving energy. If the ionization potential of hydrogen is 13.6 volt, find the energy absorbed in the transition, wavelength of emitted radiation if the atom becomes back to the initial state. Yes. Now, what do you mean by ionization energy? That I have not described in the last class. Ionization energy, ionization potential, excitation energy, excitation potential. Suppose there is an electron in the hydrogen atom, minus 13.6 eV, the lowermost energy level, that is the first orbit of hydrogen atom. And if it is asked to jump to the next energy level, you have to supply an energy of 10.2, and because the next energy level is 3.4 electron volt by 13.6 by 2 square, because in the energy equation by n square, correct? Minus z square e to the power 4m divided by 8 epsilon naught square n square h square, so minus 3.4. So this is E1 by 2 square, next one E1 by 3 square, so on, E1 by n square, that means infinity square. This is 0 electron volt, and this is n is infinity. Now it is going to n equal to 4. 1, 2, 3. An energy supplied to hydrogen atom, transition occurs from level 1 to level 4. It goes to 4th energy level. When it comes back, it gives that energy in the form of photon. Now, what do you mean by ionization potential? Energy required to excite an electron from ground state to the n equal to infinity state. That means remove the electron from the atom, ionize it. It becomes it will have a scarcity of electron, it gets turned into a positive ion, right? Because number of protons in the nucleus will be same, but number of electrons have decreased by 1. So you will have one positive charge more, so it becomes a positive ion. So energy required to lift an electron from the ground state, that means first orbit, to the highest energy state, which is n equal to infinity, 0 electron volt. So what is the energy required to lift an electron or remove an electron from the ground state of an hydrogen atom? Simply talking, So in simple way, if you want to define, ionization energy is the energy required to remove an electron from the ground state of hydrogen atom. From the basic, the maximum energy you have to calculate. Okay. What is the ionization? Ionization energy of hydrogen atom? This is 0 electron volt. Greater than minus 13.6. 0 minus of minus 13.6 plus 13.6 eV. Ionization energy for hydrogen atom is plus 13.6 eV. What do you mean by that? Your friend has made 50 lakhs loan in the bank. What is the maximum amount of money you need to give him so that he is free from everything? You have to lift him and you have to make him free from the loan of the bank. You have to give 50 lakhs itself, because his money is minus 50 lakhs. You have to give plus 50 lakhs. So if the energy in the ground state of hydrogen atom is minus 13.6, if you want to make it free, 0 electron volt, you have to give plus 13.6. So excitation energy of hydrogen atom is not minus 13.6, it is plus 13.6 electron volt. What is not excitation, ionization energy. Then what is the ionization potential? How to give that energy? Will you give it in the form of light? Will you give it in the form of heat? You should exactly give 13.6, otherwise it won't receive. If it is little less, it won't receive it and it will reject it. And or it will go to any of the higher energy state, it will come back. If you want to remove it, it should be plus 13.6 eV. Okay. Now, how to give that? Again the same thing. Take a vacuum tube, connect two electrodes into that with a high potential difference battery, and here is a coil which is heated again using different source of energy, and another battery, separate battery. When it is heated, it emits electrons, and electron as soon as comes out of the material, there is a negative potential here, there is a positive potential here, electron is repelled and attracted towards this. And that electron gains kinetic energy when it moves through an electric field. Electric field is created by this battery. Now, if V is the potential of the battery, what is the energy gained by the electron by the time it reaches here? Work done by taking a charge is a potential difference. Work done is Q into V. So what is the energy gain? Work done by the battery. So work done by the battery is the kinetic energy of the electron, which is Q into V. That is, work done is equal to Q is electron charge into V, so many joules. And if you want to convert it into electron volt, work done is equal to E into V by E, because if you want to convert any joules into electron volt, divide it by 1.6 into 10 to the power minus 19. That means V itself, so many electron volt. That means if you want to move an electron by an energy of 10 electron volt, you have to supply a potential difference of 10 volt. If you want to accelerate an electron by an energy of say, if you want to give a kinetic energy of 5 electron volt, you have to accelerate through a potential of 5 volt, because when you accelerate through a potential of 5 volt, energy gained by the electron is Q into V, 5 into 1.6 into 10 to the power minus 19, and when you convert it into electron volt, 1.6 into 10 to the power minus 19 divide, so that becomes 5 electron volt. Now I want an electron to be lifted from the ground state to the last energy state. I need an energy of 13.6 electron volt. That energy must be gained by this electron. It has to move and hit to the hydrogen atom. Hydrogen atom receives that energy and kicks itself out of the atom. And how much potential difference is needed? 13.6 volt. When a potential difference of 13.6 volt is applied between the two terminals of a vacuum tube which contains hydrogen at low pressure, electron gets a kinetic energy of this much, 13.6 electron volt. It collides with the hydrogen atom. Hydrogen atom receives that energy, kicks out one electron. That is called ionization potential. So ionization energy is the minimum energy required to remove the electron from the atom in the ground state. Ionization potential is the potential required, potential difference, battery voltage. That is called potential difference. Potential difference required to excite or to ionize an electron from the ground state to the last energy state or out of the atom. That are the two definitions. Similarly, we get excitation energy and excitation potential. What are excitation energy and excitation potential? Excitation means it is not from ground state to the last energy state. Any energy state. What do you mean by excitation energy between the first two energy states? It is the energy required to excite an electron from the ground state to the second energy state or first excited state. This is called second energy state, but first excited state. This is not excited state. This is always ground state. This is the first excited state, second excited state, third state. Third energy state is the second excited state. Out of the excited, it is the second one. Second energy state is the first excited state. So energy required to energy required to excite an electron between any two energy states is excitation energy. And the potential difference required to do this is called excitation potential. Energy required to excite an electron from the ground state to the n equal to infinity state, last energy state, is called ionization energy, and the potential required to do this is ionization potential. Now if you are asked to calculate what is the excitation energy between the second state and the third state in a hydrogen atom, this is minus 1.51 because it is minus 13.6 divided by 3 square. So what is the excitation energy between these two? Minus 1.51 minus of minus 3.4. 3.4 minus 1.51. 9 and this is 13, 8, correct? 9 ones are, yes, 14, 2, 1, 1. 1.89 electron volt. This is the excitation energy between these two. Excitation energy between these two is different. What is the excitation potential between 2 and 3? Energy states 2 and 3. Excitation potential is the potential required to excite an electron, because you need all these arrangements. That is 1.89 volt. Potential difference, if it is asked, you have to put it in volt. That is the definitions. Okay. Now come to this problem. Their question is, if the energy level N1 is equal to 1 to N2 is equal to 4. This is N2, this is N1. We have to understand it. We have to excite an electron. If the ionization potential of hydrogen is 13.6 volt, if the ionization potential of hydrogen is 13.6 volt, means you need a potential difference of 13.6 volt to that battery in the vacuum chamber, that vacuum tube connected outside, that much of voltage. That means ground state energy is minus 13.6 eV. Find the energy absorbed in the transition from here to here. What is the energy absorbed? So for that you got this one, right? What is the energy in the fourth state? You can do that. Energy in the fourth state, energy in the first state. Energy in the fourth state minus energy in the first state. That gives the energy difference, energy absorbed. Do you agree? Energy absorbed is equal to energy in the fourth state minus energy in the first state. What is the energy in the fourth state? Minus 13.6 by 4 square. What is the energy in the first state? Minus 13.6 by 1 square, because they have given ionization potential. If 13.6 volt is required for the battery, energy must be 13.6 electron volt itself. But it should be minus 13.6. Okay, so what will be the answer? This will become plus, that is equal to plus 113.6 by 1 square minus 13.6 divided by 4 square, that is 16. This one. So what is the answer? 16 common and 13.6 outside the bracket, energy absorbed. So I have to do that now. Here 16 common, this is outside the bracket. Here 1 square, 1 16s are 16 minus 16 ones are 1. 15 by 16 into 13.6. So 15 by 16 into 13.6. Got it now? One value is given. So here, you know this is by 2 square, 3 square, 4 square. So what is the difference in energy? That much you have to give. So that difference is this much. 15 by 16, 15 into 13.6 divided by 16. That is 12.75. Yes. This is 12.75 electron volts of energy is needed to lift an electron from one atom, first energy level to the fourth energy level. Suppose you are asked to find out what is the excitation potential, same number, voltage volts in a unit, 12.75 volt. Now, what is the wavelength of light emitted when this comes back like this? Either you can use 1 by lambda is equal to RH into 1 by n1 square, but it is not allowed to be used here because RH is not given. You know the states, n1 square 1 square, n2 square 4 square, but RH is not given. But you can do one thing. What is the energy, frequency, wavelength of light emitted? Wavelength of light emitted can be calculated like this. E2 minus E1 is equal to hc by lambda, h nu. H nu is hc by lambda. What is E2 minus E1? We have already calculated this. 12.75 is equal to hc by lambda. Shall I use it as it is? No, this has to be converted. Converted into joules. So shall I do it somewhere else? I will do it here. 12.75. Where is it? You have to correct this now. 12.75 electron volts, 1.6 into 10 to the power minus 19 joules must be equal to 6.6 into 10 to the power minus 34, 3 into 10 to the power 8 by lambda. What is lambda is equal to? I will cut short that. This is 19.8 into 10 to the power minus 26 divided by this one. 12.75 into 1.6. 12.75 into 1.6. 20.4 into 10 to the power minus 19. That is equal to 19.8 divided by 20.4. 0.97. 10 to the power minus 26 plus 19. 7. Minus 7. Yes. 9.7 into 10 to the power minus 8 meters. Correct answer, right? This is how we have to do. Okay, I don't have any problem further, right? So this is a little different problem. So if Rydberg constant is not given, you are not supposed to use 1 by lambda is equal to that one. In theory exam, entrance you can do that, no problem. But you have to go for this one. That is any energy states, any two energy states. If you want to find out what is the energy difference, E2 minus E1 is equal to hc by lambda or h nu. You can use this formula. And if only ground state energy is given, second it E1 by n square minus E1, E1, this is equal to hc by lambda. You can use like this. First energy state is E1. Any of the higher energy state by n square. So use that difference, you can get the answer. So this is about the problems. I don't work out more problems. It is your job. Take some problems as homework and you can work it out. Okay, completely work out all the problems in that because you will have enough time. So you will get the answer for that. Suppose you have any doubts, you can ask me. So thanks for watching my class. Take care of your health. Don't waste time. Again, same things are getting repeated at the end of the class, but still I have to repeat it. Otherwise, it won't enter into your brain. So we will meet in the next class with some entrance exam problems on dual nature of light, right? Photoelectric effect and all. Okay, thanks for watching the class. Don't waste time, work well. Thank you.